Okay, so let's just briefly kind of recap where we've been, where we're going. We have finished module 4 as of yesterday, and if you didn't get a chance to do that test yet, you can open it back up by clicking on request extension and automatic. This week, we're going to be looking at module 5 and 10, as you see on the right-hand menu there. So as you practice those and get ready, for example, if you feel prepared in Unit 5, by midweek, you can go ahead and tackle that test. My only kind of latest ask is that you do both of those by next Monday before we meet Tuesday of next week. What, 5 and 10? From what I'm seeing, those of you here are doing very well. I see your tests are consistently at 70% or more. So I like that. I like to see that. And I want you to try to maintain that as we continue forward. What I've done is kind of just outlined what we're doing this week here. If you haven't noticed already, I have video links to our classes from previous weeks. If you just click on the day, like for example, back here, we were looking at module 3, I believe. If you ever wanted a recap of some stuff we did from class, you can click on those. You don't have to watch those. Those are just there for your reference. Any questions about online stuff? Finding anything at all before I put the screen up? So if you take a look at your Module 5 packet, first, let me just ask you, are there any questions from Module 4 that you want to throw at me real quick before we look at Module 5? Anything at all? Feeling okay about that stuff? Good. So Module 5 is all about variable expressions, okay? And so what we're building to is that ability to, say, solve equations, work with functions, graph functions, things that we'll see in college algebra in the fall. And Module 5 has, as a kind of general outline, 3 primary sections. The first one being about evaluating or plugging in stuff into the variables. The second one being simplifying expressions, combining like terms, and then the third one being translating into expressions. I've taken the liberty to kind of condense our packet this week. You may see it looks a little bit different. So just to kind of walk you through quickly, I have an explanation of each section followed by examples that are sort of brief. And then you'll see practice problems for each individual piece of each section, like A, B, C. And I tried to give you enough space with those practice problems so that you could practice and write out your work, okay? So let's start just by looking at the front where it says evaluate a variable expression. The goal with that is with some expression, I'm looking at that first example as I start here, where it says a minus 2b in paren squared. It gives us values to assume for the variables a and b, being -2 for a, -3 for b. So if we're asked to evaluate an expression given some input, then we want to put those numbers into the expression and then use our order of operations, like we talked about a week or two ago. So -2 going in here for A minus 2 times B, and I'm just kind of creating an extra set of parentheses to put B in here since it's a negative. I've got times -3 there. However you want to kind of hold yourself accountable for that is fine. You could just as well have written -2 minus 2 times -3, just as long as you're being careful that you know there's a -3 in there and it's multiplied by this. Okay. So let's try to simplify this. If we've got minus something, we've talked in the past about just changing that to addition, plus -2 times -3 squared. And then what do we get out of this? -2 times -3. +6. Good. Positive because we got two negatives, even number of them, and 2 times 3 for 6. Then bring everything else down. And we have these things inside the parentheses that we need to operate with before we do the squaring. The -2 and 6 combine for what? 4. And we're squaring after that. 4 times 4 was 16. Right? Not too bad. Let's just kind of walk that through just to identify some of those key areas. One was recognizing that this part is kind of like the multiplication of two negatives. And that multiplication was necessary before we could add within the parentheses, right? So don't get too hung up on this ordering. Even though we have parentheses, there's a whole set of stuff inside there that we have to handle. So it's kind of like we have to put this on pause for a moment and ask ourselves, are there these things going on within there? Yeah, we have multiplication going on here, and then we add addition after that. Once we do all of that within the parentheses here, then we can do the exponent. So sometimes there's some sort of cycling through this that goes on. It's not always just matter of fact P, E, and D, A, F in that order. A lot of times you'll be kind of in a place where P has to be on pause for a minute. You do everything within the parentheses, and then you can move back through. Let's just look at that second example. Notice it says x minus the group 2 minus y over z cubed. Want to walk through that one? Number 2 on the examples. Or are you feeling like you'd be okay with that? Want to walk through it? Okay. So I'm going to move this. Number 2 in our example 4, 518 says x minus 2 minus y over z cubed. And I'm going to write down our numbers that give us x -4, y 12, z -3. We're going to substitute all of those in here and then see what we need to do order-wise. We've got a -4 going in the place of x minus a 2 minus 12 divided by -3, and that paren is going to be cubed. What would you start with? You could distribute some negative sign, but I'm gonna stop you there because distributing to a set of parentheses um, has to happen to one that's only to the first power. Okay, so I like um, your idea. We're gonna use that a lot, but we have to be careful when we have that power on the paren. What else? What if we look within the parentheses? What would we do first within there? Yeah, let's try that. What's that? 2 minus what? 12 divided -3 for -4. Mm-hmm. So we have 2 minus -4 in here. I'm just going to rewrite that with addition. 2 plus 4. You can always change to addition and change the sign of the neighbor there. Then what can we do next? Good. And say that again, Jackie. To the third power on that 6, what does that give us? Feel free to rely on your calculator for things that escalate quickly like that. 6 times 6 is 36 times 6 again, or use your caret key in the 3 for the exponent. Check my math on that. I get 216. Check your math on that. Good. We agreed on that. And so then what? Okay. So we're kind of like, we've been through this in the parentheses, then we cycle kind of back through, don't have any more of this. We're at the adding and subtracting stage. And if you needed to, if you're in the habit of always converting to addition, which can be useful, then we'd be looking at it that way. -4 plus some more negative for -220. Just verify for yourself that that's what you would get from this with this. -220. Mhm. Just taking your um, taking your time to understand the process is useful with these practice problems. Try more of them from 5.1a. Make sure you're comfortable with that process of um, substituting values that are given and evaluating to get to the answer you want. Then wrap all of that because we're about to have just the variables in there. Okay. So looking at 5.2, where we're simplifying variable expressions, notice like terms is highlighted there. that is going to be what we're looking for all the time, basically, when we're trying to simplify variable expressions. And we can use things like the distributive property London just mentioned. There's other properties I don't expect you to kind of memorize them or know them, and like the theory of them. I don't expect you to be able to say A times B is always equal to B times A, and that's commutative. I don't expect you to know all of these properties. They are just kind of given there as a guide. And what I want us to do is start with that first example on the second page or the back of the first page. This is 5-2, example number 1, combining like terms. It says simplify. There's the word and change there. Those were evaluate over there. 3x squared minus xy minus 5y squared plus y squared minus 4x squared plus 2xy. Okay. Now, things that we look for like terms. Anything you want to share with me just by intuition, what you would look for if you're trying to decide whether these two are alike or different? What kind of things do you ask yourself? One thing we can ask is the same letter in there, right? That's one place to start. We're looking for like terms to combine. Yep. If they are, then we can do so. Let's just play a game where you try to tell me what, if any, is a like term to, our greens are not working. What, if any, is a like term to 3x squared? Negative 4x squared. Good, Lyndon. Thank you for sharing that. And I like that you highlighted the subtraction sign that is in front of it. We do want to think of that like it's attached. Okay. So why are those two alike? They have the same letter, and that letter has the same power as well. Those two things need to agree on all aspects of the term. Okay. This is not like because it's got a different letter. This is not like because it has a different power and different letter. So what about x squared terms? How many of them do we have? 3 plus negative 4 for negative 1. And I'm just going to write that for a minute. We don't need to write ones in front of variables. I'm just going to kind of take an accounting. Yeah. Now let's look for whether we have something that is like negative xy. See something, Jackie? You see a term that looks like negative xy? That one. Why? Because it has x to the first power and y to the first power. So it agrees on all elements of the term. All aspects of the terms agree. The numbers don't have to agree. The numbers in front. We operate on those. Negative 1 is assumed here. Plus 2 is 1. Positive 1, right? And you can write yourself a 1 in there if you need. To visualize that, negative 1 plus 2, that gives me positive 1. Moving right along, we have this one. Negative 5y squared The only other term we have left is this one, and it happens to agree. Positive 1 y squared, negative 5 and 1 combined for what? Negative 4. We got to think back to those addition and subtraction rules, yeah. Higher number gets the sign, and they're different signs, so we're subtracting them. Yep. And you bring along our variable part. Then clean up your ones by omitting them. Negative x squared plus xy minus 4y squared. And we have to leave that alone. We have to resist the impulse to try to combine any of those things further because none of them agree in letter or power. They're understood ones on this one. Okay. These? Are you asking about these? They're different letter. Hmm? Different letter here makes them unlike, not combining them. Okay. Back here, these two do match. Okay. So they were combined into this. Did y'all wake at 4 o'clock this morning? Like I did? With the thunder and everything? It was so loud and just lights flashing all the time, even through the blinds and everything. Yeah. Because of all the activity in it. Yeah. My dog is similar, very um, cuddly and timid when it gets too loud from the thunder or fireworks. Yeah. All right, let's take a look at number 2. And you got kind of a hint there that we're going to be using the distributive property. You won't always have that. That's just kind of help get us started. On this example, we're to simplify negative 4 times negative x minus 2i plus 3 halves z. So notice one thing I did there immediately was I just kind of simplified our view because this is how you see it on the paper. But that's a 3 halves z. 3 halves z. Okay. We don't really need that paren around the 3/2. Okay. Now, we're going to distribute because none of these things can be combined. They're all a different letter, right? So we can't do anything within the parentheses, and it's in this case where we turn to distribution. We're going to say negative 4 times the first term, so negative 4 times negative x, and then second term, negative 4 times negative 2y. Third term, negative 4 times 3 halves z. And then let's just work across. These two create positive. 4 times x. 4 times x, we can write 4x. Assume multiplication between them. Negative and negative again here for positive. 4 times 2 for 8 with a y on it. See, 1. Looks like negative times positive, so this is going to be minus for negative. And if you are multiplying whole number times fraction, think of your whole number over 1. And then 4 over 1 times 3 over 2, multiply across the top and across the bottom for 12 over 2. This is the whole 4 here. 4 times 3 halves. So before you just multiply all of those numbers, set it up like fraction multiplication. Whole 4 is 4 over 1 times that 3 over 2. Just multiply the top ones separately from the bottom ones. And that gives us 12 over 2, which is 6. So then come over here, place that 6 and C. And we're done there. We have one more example for 5.2 that we're going to look at. And it just says general, not really a tip. We might be applying any of the things that we've talked about so far on this last example. Let's just get it written down here. We have 3x minus 2 bracket, which can be interpreted the same way as parentheses. 4x minus 3 times negative x minus 5. Okay. Lots of parentheses here. Start with your innermost. Can we combine these? Negative x and negative 5. Can't combine number with variable. This is a constant. This is a variable. So leave them alone. If we have to leave alone within the parentheses here, then we have to step out and distribute this. So negative 3 times both of those terms. I'm just going to write down everything else coming before it. And then write that out very carefully. Negative 3 times negative x. Negative 3 times negative 5. Okay. Then we'll bring down all this stuff again. Do these. Negative times negative, positive. 3 times x. Negative times negative again here for positive what? 3 times 15. I'm sorry, 3 times 5. And I gave you the number 15. So, yeah, you can view the square bracket same as a paren. Now that we have all of these, and we want to operate within our parentheses like we normally do, tell me, are any of these alike? Yeah. So what would they combine to, Jackie? There's a plus in between them. 7 times x. Mhm. That times x sticks around. That times x sticks around. The operation, you look between them and do that on the number part. Okay. Then bring down our plus 15 here. Can we operate on these together? No. Yeah. So we got to come out here again to that distribution. 3x minus 2 times 7x minus 2 times 15. And minus 2 again times our 15. Mhm. Each term within the bracket or param gets multiplied by what's in front of it. Okay? Then 3x, and what do I have after that 3x? Two times 7 with our x. And how about the sign? Is it plus or minus here? Negative. So I have one negative, one positive. Those multiply are negative. And looks like the same sign set up over here. Negative times positive, 2 times 15, 30. What more can we do here? What is that going to give us? You're multiplying still between those two terms. I heard of 42. That's 3 times. What's 3 minus 14? So negative 11 x minus 30. So at that point, you have to resist at that point. That's the stopping place right there. Because we have variable x to the first power here, constant x to the nothing here, no x. So that is not like that, therefore I leave it. So that gives you a view of what kinds of things you're doing when you try to simplify expressions. We looked at distributing, we looked at distributing and combining, distributing some more, combining some more. So you've got all the tools ready. You just want to practice some more of them on the simplifying. The last section, 5.3, you can still hear me. Can barely hear myself. I said, if you can still hear me, I can barely hear myself this rain. We're translating expressions. For example, 8 less than z, 8 less than z. Less than, what kind of operation would you intuitively think is being used to translate less than? What's 5 less than 7? 2, right? So we do this in translating that. So what are we doing here? Z minus 8. 8 less than z. So it's not like we just plop a subtraction sign in there if it's worded that way. Less than, you kind of reverse the order, put a subtraction in there. We've got the product and the quotient. We've seen that term before. Product means multiply. The product of x and y, x times y. Quotient of x and y, x divided by y. The square of, we haven't seen that yet. The square of w. If you see the square of, that means to take it to the second power, squared. So the square of something, you take that thing and put a square on it. That's the interpretation for square. Now, let's try some that are a mixture of things. We've got 5 times the difference of m and 3. The difference of m and 3. When you've got multiple things going on, I recommend kind of just making notes and blocking things off for yourself. For example, I might highlight difference of m and 3, that's m minus 3. Difference of subtraction. And then I've got a 5 times. Now, if I have a grouping of things going on, doing something, and then I multiply something by it, remember our distribution? That's kind of what's being set up there. 5 times that. So 5 times the difference of m and 3. Try to slash the sample. 12 decreased by the sum of 9 and z. The 12 decreased by, that's 12 minus, right? The sum of 9 and z, that's going to be the sum of blank and blank, that's a grouping. So 9 plus z is the sum of 9 and z. Notice how when we have this going on, we have groupings typically. Not all the time is that interpretation matter of fact like that, but I would say more times than not, or most of the time, if you have a bunch of stuff something going on, then that's a grouped quantity. Okay. The sum of 9 and D is what is being taken off, or what 12 is decreased by. Let's take a look at translating and then simplifying after we translate. Suppose that we have translate and simplify as the instruction. And that stuff simplify. That stuff that we're to translate, let's take the example 3 subtracted from 1/2. One half of, I'm already putting my 1/2 in there, get a word, the sum of 5 and the square of a number. Of a number. Now this one is pretty complex. Don't beat yourself up if these are kind of like on your not so comfortable zone. I wouldn't expect you to be able to do this over and over again in college algebra. I mean, practice it. Good for being nimble and, skilled for other purposes, but don't beat yourself up if these are giving you trouble because they're complicated. I know. Let's focus in on this part and the fact that we're not given a letter. So you choose your favorite letter. I'm going to say P for that number, okay? So that I'm going to square the square of that number, summed, looking kind of backward this way, that is summed with 5. Got an of here, so this is grouped 1/2 of it, so it's multiplied by 1/2, and 3 subtracted from means it's over here, minus 3. That's a lot of words to translate. And I'm just going to briefly show the simplifying part. 1/2 distributed here means we got 1/2 times 5 plus 1/2 times p squared, and then a minus 3 coming down. One half times that whole 5. Remember, place that whole number over 1 to set up that 1/2 times 5 over 1 plus 1/2 times the variable. You can just write the fraction and then the variable part next to the fraction. Clearly next to it, not on the denominator. Okay? And then minus 3 over here. To this part, we can simplify a little bit by multiplying across the top, multiplying across the bottom. 1 times 5 over 2 times 1. Then plus 1/2 p squared minus 3. Do we have any like terms we could potentially combine? V2. This one's attached to the variable. So watch out for that. Variable term here, constant term here is how we want to think about this. Do I have any other constant term? -3. That's another constant term, another number without variable. So 5/2 can be combined with -3. I know we don't want to do it, but it can be. So 5/2 -3. That's 5/2 minus 3 over 1. How do I get those up to the same denominator? Multiply this one by 2 on the top and bottom, right? So I have 2 here, 6 there. Now I can do 5 minus 6 is -1 over my common denominator of 2. So what we just did is we said this term and this term are like. We combine them to get this. -1/2. Those come into and then bring down our 1/2 t squared variable term. So what do we have in the end? We have a constant term, only number, plus a variable term, and that variable term happens to be a square term. Second power. So they are not like. At this point, we would want to resist any temptation to get those together. You might try to say -1/2 plus 1/2 is 0. We don't have 0 t squared. I want to stop right here because this is number, no variable. This is variable. And so no playing mixed up with those. Okay? All right. That's going to conclude our overview of Module 5. So I'm going to stop the recording.